This is a definition of direct proportion. Remember, two amounts are said to be in direct proportion when as one amount increases, another amount increases at the same rate. I will look at an example. Um, let's pick one example. Suppose Nancy is paid per hour, and suppose she's paid $20 per hour. So this is her rate of her income. If she works for 2 hours, that means that she'll be paid $40. So if she works for 2 hours, she will be paid $40. If she works for 3 hours, she'll be paid $60. And so on. So what we are saying here is how much she earns is directly proportional to what to how many hours she works. So if she works for more hours, she'll be paid more. So how much she earns is directly proportional to how many hours she works. And this makes sense. She works for more hours, she will be paid more. She works for less hours, she will be paid less. We can actually illustrate this in a graph. So suppose our y-axis represents Nancy's income, and our x-axis represents the hours that she has worked. We can draw a graph showing how her income is the relationship between her income and the number of hours. So for 1 hour, say she's paid $20. So 1 hour, she gets $20. So income is in dollars. 2 hours, so in 2 hours she's paid $40. 3 hours, suppose she get $60. So we can draw a graph, to show this relationship. And our graph will be something similar to this, a kind of a straight line. Mine is just a sketch, but you can see that her income is actually directly proportional to the number of hours that she has worked. So we can say, in summary, income is equal to 20 multiplied by hours worked. And this is very important. This is very, because this actually summarizes what's happening here. Now this 20 has a special name. We call it constant of proportionality. Okay, so it's called a constant of proportionality. Once you get into year 10, you'll discuss more about the constant of proportionality. But this is the whole idea of direct proportion. Here is an example. A farmer plants 5 apple trees in 25 minutes. If he continues to work at the same rate, how long will it take to plant 200 trees? So we can start by setting up this question. So we can say 5 trees are planted in 25 minutes, which means that one tree will be, of course, that will be less time because 5 trees take 25 minutes. One tree will be 25 divided by 5, which will be 5 minutes. Makes sense? And actually, this 5 here is our constant of proportionality. So, and you can use that constant of proportionality to work out the number of minutes required for any number of trees. So, in this case, they're asking how long it will take to plant 20 trees, 200 trees. So 200 trees so 200 trees will be, of course, that will take more time. So we'll just multiply 200 multiply by how much it takes to plant one tree, which will be 1,000 minutes. Here is another example. A machine prints 4 books in 10 minutes. How many books will it print in 120 minutes? Now, this is usually how I work these questions out. I look at what has been asked, and I usually order that on the right, while what I have been given, I usually order that, arrange that on the left. So this is what I mean. They're asking how many books, so that will be on the right of the equation, and whatever I'm given, which is 10 minutes and 20 minutes, that will be on the left. So in 10 minutes, four books are printed, which means that in 1 minute, we'll have 4/10 book. It doesn't make sense, of course, 4/10 books, because you know that books has to be a whole number, but this is our constant of proportionality. So we'll just write what it is. This is our constant of proportionality. And you're going to use it to find the missing part of this. So, so that means that in 120 minutes, if 1 minute that part of the book is printed, that means in 120 we are going to multiply that by 120, so that will be 0.4 multiplied by 120, which will give us 48 books.